In this unit, we'll be talking about chemical bonds, how atoms come together to make bonds and molecules. And so this is notes number 18, called chemical bonding. Our first questions of these notes are, how are atoms held together? Atoms are held together through chemical bonds, which is the force that holds two or more atoms together. So chemical bonds can form in two different ways. The first way is for the positive nucleus of one atom to be attracted to the negative electrons of a different atom. Or the second way is because of an attraction between a positive ion, which is a positively charged atom, and a negative ion, or a negatively charged atom. Now this is called what's called electrostatic attraction, the attraction between a positive and negative. So here's a picture of electrostatic attraction. It's where a negative and a positive something are going to attract each other, pull each other closer together. And then repulsion, which we'll also talk about in a little bit, is where the same positives are going to repulse or be away from each other, and then also two negative things will also repulse or go away from each other. Our second question is, what characteristics of atoms contribute to bonding, or what part of the atom is responsible for bonding? There are three characteristics of atoms that contribute to bonding, and the first and most important is the atom's valence electrons. They are the ones that are actually involved in bonding, and remember, the valence electrons are the ones on the very outermost shell. So this atom here has 4 valence electrons because there's 4 of them on the very outermost shell, the furthest away from the nucleus. The second characteristic of atoms that contribute to bonding is the atom's ionization energy. Now, we talked about this when we talked about the periodic table trends, and ionization energy is the energy needed to remove an electron from an atom. So this is going to affect the bonding ability of atoms. If atoms have low ionization energy, meaning that it's very easy for atoms to lose their electrons, then they will be making one certain type of bond. But if they have very high ionization energy, meaning that it's very hard to take away the electrons of an atom, then they're going to join with different kinds of atoms to make certain bonds. Now, if you recall, the ionization energy trend on the periodic table is that it increases going from left to right, and it decreases going downwards. So you're going to find the atoms that have the highest energy needed to remove electrons over here on this side of the periodic table, the top or right hand side, and the atoms with the lowest ionization energy is down here on the bottom left hand side. So they're the easiest to remove electrons from. And the last characteristic that goes hand in hand with ionization energy is the atom's electronegativity, which is the ability to attract electrons. That also is going to affect bonding, and we'll see how. And remember, the periodic table trend for that is that, again, just like ionization energy, electronegativity increases going across from left to right. So you're going to find the atoms with the highest electronegativity on the top right-hand side of the periodic table, and it decreases going down, so you're going to find the atoms with the lowest electronegativity, or the lowest ability to attract electrons, down here on the lower left-hand side. The next question has to do with the lab demonstration that we're going to do next class. We're going to be testing different chemicals and seeing if they conduct electricity while in the solid state versus in the liquid state. And so what we need to do is we need to know the difference between a solute and a solvent. The solute is the substance of lower quantity that's being dissolved. Okay, and the solvent is the substance of higher quantity that's doing the dissolving. So if we look here at the picture, the sugar, all right, is what we call the solute because it's going to be dumped in and is going to be dissolved. And the the water here is the solvent, okay, because it's the one that's dissolving the sugar. It's doing the dissolving. All right, here. So we've got the solute, which is being dissolved, and the solvent, which is doing the dissolving. All right, our last and final question for these notes is what kinds of chemical bonds exist? So here we're going to actually look at the meat of this unit, and as we go through this unit, we're going to dissect each of these kinds of chemical bonds. The first kind of bond that we're going to cover is called a metallic bond. Metallic bonds form between two or more metal atoms, and tomorrow when we are testing these substances, we're going to see that those substances that are held together by a metallic bond will conduct electricity, but they will not dissolve in water. Okay? And then, so the structure of a metallic bond, as we'll see here, is what's called a sea of delocalized electrons. So the electrons are kind of just scattering around all of the nuclei, and they move kind of wherever. So it's really easy for electrons to jump around, and so that's why it makes it so easy for them to be able to conduct electricity, because the electrons are able to just kind of move around wherever they want to in this type of compound, in this type of bond. The second kind of chemical bond that exists is what's called an ionic bond. These bonds form between a metal atom and a non-metal atom. Okay, so from both sides of the periodic table, the left side and the right side. Substances in these, we'll find out, or we'll see tomorrow, is that these substances will dissolve in water, but they will conduct electricity only when they're dissolved, though, not when they're dry. So we'll see how that works. Now, electrons, which are the ones that are involved in bonding in ionic bonds, are what we call transferred from the metal atom to the non-metal atom. So we see here in this picture, we have a metal atom, sodium. He's on the left side of the periodic table. He has one valence electron right here, and he's going to give that valence electron to a non-metal atom, chlorine. If you look on your periodic table, chlorine is on the right-hand side. So we have a transferring or a giving away of a valence electron from a metal atom to a non-metal atom, right, to form what's called an ionic bond. Now, when the sodium loses its electron, it becomes a positively charged ion, and when the chlorine atom gains an electron, it's a negatively charged atom. So these two charges are going to attract each other, all right, in what's called electrostatic attraction, and they're going to hold the atoms together in a bond. The third type of chemical bond that we're going to study is the molecular covalent bond. These bonds form between two or more non-metal atoms. So we're talking about the atoms on the right-hand side of the periodic table hooking up with each other. All right, so in a molecular covalent bond, these substances are usually liquids, gases, or solids that are able to dissolve in water. So what we call soft solids. Now, we'll see in our experiment that these substances will not conduct electricity, whether they are dry or dissolved in water. Now, in molecular covalent bonds, electrons are shared between the two atoms. Okay, so instead of a transferring of electrons like we saw in ionic bonds, in molecular covalent bonds, we have a sharing of electrons. So sharing is caring, and caring is covalent. So that's the molecular covalent bond. Our last kind of bond that we're going to talk about is what's called a covalent network bond. And again, it's a covalent bond, so it's very similar to the molecular covalent bond, where it forms between two or more non-metal atoms. Now, the difference is that covalent network bonds form between hard solids that cannot be dissolved. Right, so it's a covalent bond between two or more non-metal atoms that are so tightly packed together, so strongly held together that not even water will separate them. All right, so in this kind of bond, the electrons, again, are shared between the two atoms. Okay, so we have the electrons here being shared between the two atoms, and that sharing is so tight that we can think about them being so tight that not even water can break them apart to dissolve them. All right, and so that's the end of these notes, and we'll see you tomorrow for our lab demonstration.